Hi guys! Chemical Bonding Brothers are back! Now today, very sadly, is going to be our last video with you guys. That is okay. Now we're going to start off today's lesson by doing a recall of the important intermolecular forces of attraction for simple covalent structures. So first of all, we have the ID-ID interactions, PD-PD interactions, and hydrogen bonds.
So William, to do a recap, what do we need?
We need the encyclopedia. Get it ready.
Okay, William, so let's start off with the first interaction, instantaneous dipole-induced dipole interactions, or ID-ID interactions. Now, please recall that this is the predominant force in non-polar molecules. And how does this force arise? Simply put, at a particular point in time, because electrons are moving, so there might be an uneven distribution of electron cloud, creating a particular dipole in a molecule. This dipole will make a neighboring molecule have a dipole, so this is what we call, it induces a dipole in a neighboring molecule. Therefore, there will be an interaction between the delta plus on one molecule and the delta minus on the other molecule. So this is the basis of ID-ID interactions.
Alright, now if we compare ID-ID against PD-PD, the main difference is who does PD-PD interactions with
So if you see the name, it's a permanent dipole, so the dipole is always there, so it must be for polar molecules, right?
Yes, you're right. So in an event, you have molecules that are polar in nature. Predominant interaction is going to be permanent dipole. So if you take a look at your notes, we went through an example with you guys previously on HCl. Right, so if you focus on H versus Cl, the delta plus and the delta minus are going to be permanently there, right? Because chlorine is always going to be more electronegative. So how do various HCl molecules position themselves is always done such that the delta minus of one molecule is aligned next to the delta plus of a neighboring molecule. And what will they have? They will have this permanent dipole interaction between them. And because the interaction is permanent, so we do kind of expect that PD-PD to some extent is going to be stronger than ID-ID, provided
that the size of the electron cloud of both molecules of concern is about the same.
Yep, right. So it's always important to check the amount of electrons that they have to ensure that ID-ID is approximately constant.
Okay, so the third force would be hydrogen bonds. So for hydrogen bond to exist, two criteria must be satisfied. Firstly, the hydrogen atom must be bonded to what we call the full of nonsense, FON.
Just like you, huh?
Okay, so the H atom must be bonded to FON because these are the three most highly electronegative elements. Now, on the neighboring molecule, this F or N must have at least one lone pair of electrons that is available to attract the delta plus. Okay, so if you were to look at the diagram over here, so between two molecules, alright, so let's look at the water molecule on the right hand side first. The H atom is bonded to oxygen, so it is delta plus. On the neighboring oxygen atom, there are two lone pairs of electrons, so this lone pair will attract the delta plus of the other H on the other water molecule, and that particular interaction is a very strong interaction called hydrogen bond.
Now when we draw hydrogen bond, we did explain that there is an acronym that they have to follow. Remember?
Yes.
It's not plan A, it's not plan B, but
Also not plan C leh?
not plan C.
Then it's plan what?
It's plan D.
Plan D.
Guys,
Plan
remember
D.
plan D. Alright, now
Okay.
what does plan D stands for? Let's write this down. Okay, so we have plan D. Now what does P stands for?
Polarity.
Okay, so the polarity. So the polarity will refer to the delta plus and the delta minus. As you can see here, we have to label delta plus and delta minus. Now what about L?
L stands for lone pair.
Right, the lone pair. Right, the lone pair on the either NO or F. So you can see here the lone pairs must always be drawn.
Yep.
Yeah, what about A?
A is the arrow, right?
Yeah, the arrow. Okay, where's the arrow? I don't see the arrow. Well, actually it's here. Can you see? There's an arrow, alright? So we have to label, right, and tell people that this is the hydrogen bond.
Yep.
And what is N?
And it's the name of the interaction, which is hydrogen bond.
Alright, so over here you can see hydrogen bond, so you have to go name it. And the last thing is D. D for?
I don't know, you tell me.
D for dog.
Oh, got dog man this diagram?
Don't know.
Don't have lah. So the D must be this green color thing that you highlighted, right? It's a dotted line.
Dotted line.
Dotted line.
Dotted line. Alright,
Dotted
now
line.
it stands for the dotted line. Alright. So these are generally, I would say, the marking criteria, what examiners are looking for when you're drawing hydrogen bonding. So just remember, plan D. When all things fails, plan D will work for hydrogen bond.
Okay, so thanks for the quick recap of the three intermolecular forces of attraction. Okay,